Hello everybody. Today we are going to work on lesson 12.1. So this is just continuing our unit on systems of equations. Homework for this assignment is going to be on pages 435 through 438. 2 through 16 even. So the difference between this lesson and what you've been doing so far is they've pretty much been giving you systems to solve, and you've solved them by graphing, substitution, or elimination. But today, you are going to be given a situation that you could use systems to solve, but you will have to create the system yourself before being able to solve it. So the examples on the front of this page are a great review of things that we've already kind of talked about and done, but they are not going to go exactly hand in hand with this lesson. So all of the notes we do today are just going to go on the back side in extra notes. So if you want to go ahead and flip it over to the back side, basically you're going to be asked to create a system based on a verbal description, which means a word problem, or they may give you a table of information and ask you to create a system based on that table of information. And they're also going to ask you to write a system from some graphs and solve it. I'll show you some examples of that in your actual homework before I turn you loose to start. So go ahead and create a section first. Let's focus on verbal descriptions, those word problems. What I'm going to remind you about is that if you are going to be given a verbal description of a system, they're going to talk to you somewhere within that problem about rate of change and initial value. They are not going to come right out and say, hey, here's the slope of this equation and here's the y-intercept of this equation. But if you look for what's changing in this problem and interpret that as that's my slope, and where did they start from, where were they at initially, what was the initial amount that they started with or the initial place they started from, that will be your y-intercept. So if we'll use these things that we know from past lessons, we should be able to read the description, write two nice equations for our equations in slope-intercept form or possibly another format, but we're going to have to just take a look at one in order to be able to make this work. So everybody needs to catch up to this point. And then we need to open textbooks to page 431 so that you can actually read the verbal description or word problem that goes along with your turn number 3. So feel free to pause if necessary until everyone gets there. And then here is that problem. So let's read through it first, and then we'll understand what we need to be able to do. Directions are going to say, determine when the cost of the two services will be the same amount and what that price will be. So if we read through number 3, they tell us that one cable television provider has a $60 setup fee and charges $80 per month. And another cable provider has a $160 equipment fee and charges $70 per month. So you will need two equations. That's why this is a system. You'll need one for the first cable provider, another for the second cable provider. So let's look at the first one. If you look at this and you ask yourself, okay, what is the initial upfront amount that this cable provider is going to charge? That's your $60 setup fee. That's your y-intercept. If they're going to charge you $80 a month, you want to understand that as the year goes on, you are going to increasingly change the amount you have paid by $80 every month. That's your rate of change. The monthly fee there is your your slope, sorry. So let's start setting up your system. We're going to draw our little system bracket here. And so we would have y equals 80x plus 60. They charge that setup fee of $60 plus $80 a month. And then if you go back and you take a look at the second provider, okay, remember how it said that they have a $160 equipment fee. You're going to have to pay that just to get the equipment that you need for their service. And then they charge $70 a month. So the $160 is your y-intercept, the $70 a month is your slope. So we would have y equals 70x plus 160. Okay, so then you want to use what we've learned and think, okay, what do I want to do? Do I want to graph this? Do I want to do substitution, or do I want to do elimination? Okay, well, I'm going to guess that none of you in your right mind said you wanted to graph this, so let's probably rule out graphing. If I were going to do this problem and choose between substitution or elimination, guys, this thing is perfectly set up for substitution. You already know y equals 80x plus 60. So just go replace the y with 80x plus 60 equals 70x plus 160. So I would totally use substitution on this one. Okay, so let's solve it. I'm going to subtract 70x on each side, which will leave me 10x plus 60 equals 160. I'm going to subtract 60 on each side, which will leave me 10x equals 100. And then I'm going to divide by 10 and get x equals 10. So you want to look at what that means to answer the question appropriately. See how your equation was 80x plus 60, $80 a month plus $60 setup fee. So when you answer x, you want to ask yourself, okay, what does x stand for in this problem? X was your number a month, like $80 a month, $70 a month. So it's going to take 10 months for the cost of these two different service providers to come out equal as the same amount. So after 10 months, you'd pay the same thing, regardless of which service you chose. But then they want to know, what will that price be? So now that you know X, just go plug it back into either one of these. I'm going to do the top one just because it seems to have numbers I'd rather work with. Doesn't matter. So I'm going to do y equals 80 times 10 plus 60 because I've plugged in 10 for X. So that's y equals 800 plus 60, which means y equals 860, but we want to understand, put a dollar sign in front of that, because then you're at least showing that you understand this is not an ordered pair. We don't want to write 1060 in parentheses with a comma in the middle. We're trying to answer their questions. When will they come out the same? After 10 months. What will that price be after 10 months? You will have paid $860 total for either service provider. So you want to be able to read a situation, write equations to make your system, and solve. Okay, and if you happen to find one where elimination is better, use elimination. This one, substitution, was definitely a wise choice. Okay, so let's take a look at how we would deal with tables. So I'm going to give you guys a second to get this down. If you have problems today that are tables, you're also going to need to be able to look at those tables and figure out how to write your equations. So you're going to have to be able to pick out slope and y-intercept. So from a table, it might be helpful to remember that to find slope from a table, you can either think of it as change in y over change in x, or y2 minus y1 over x2 minus x1. And to find the y-intercept, you're going to look at the value of y where x equals 0. Like, where would 0 be in this table and what would be next to the 0? So we'll review how to do all of that, but you want to make sure you have notes down on how you're going to find the slope and y-intercept when you're looking at your table. And then you guys even want to take time to copy this down. We are going to look at the actual book so you understand the problem, but I'm just going to tell you, even once we read the problem in the book, you're going to need this down on your paper. Otherwise, it's going to be really hard to show your work and understand what it meant. So take the time you need to copy down this problem, and then get your book to page 433 and look at your turn number 6. Okay, so again, even while you're still copying this, it's on 433, it's in the book on number 6. You guys can be copying it. We're going to take a look at the directions though. So what it's going to say is use the cost tables for two services to create a linear system of equations. Then solve the system to determine when the cost of the two services will be equal. Okay, so we're working right here. Okay, these are two beachfront stores that rent out surfboards according to the following table. So they charge by the hour. Okay, you have a choice to rent your surfboard from Hang 10 or rent it from WaveRider. So you've got your table of prices, and what you're going to need to do is create an equation for each of these two surf shops. Okay, so in order to do that, we need slope and y-intercept. So here's what I'm going to remind you how to do. Okay, let's work on Hang 10 first. I'm going to put my little deal out to the side, and we'll write our equations over here. I need to figure out the slope and y-intercept for Hang 10. Okay, so when I say that slope is change in y over change in x, okay, time is your x, pretty much always, okay, and this is your y. So what you want to do is figure out how much, there's going to be some sort of a pattern happening here. This goes 28, 48, 68, 88. Hopefully you see the pattern there. We are going up by 20 every time, correct? But over here in the x column, we're only going up by 1. So your change in y is 20, your change in x is 1, 20 over 1 is 20. So your slope is y equals 20x. Now we got to figure out y-intercept. I said y-intercept is the value of y where x equals 0. Well, you have 1, 2, 3, 4 in the x column. You don't have 0. Okay, so let's put 0 up here. 0 would be above the 1, right? 0, 1, 2, 3, 4. Okay, we'll back your pattern up. It's kind of like when we would find f of 0. What would come before 28 in this pattern? If this goes 88, 68, 48, 28, what would come next? It would have been an 8, right? So you would say that your equation for Hang 10 is y equals 20x plus 8. The slope is 20. The y-intercept, or the initial value, or the f of 0, is 8. Same thing for WaveRider. Find the pattern. This is increasing by $17 every hour. 17 over 1, 17 over 1, 17 over 1. So you're going to have y equals 17x, okay, plus you have to figure out, if this is going up by 17, what would come before here? What would be f of 0? So if you just do 46 minus 17, you guys should end up with 29. Okay, so y equals 17x plus 29. Okay, so now you solve. I would totally solve that by substitution again. If y equals 20x plus 8, I would plug it in for the other y. So I would do 20x plus 8 equals 17x plus 29. Get your x's on the same side, so I would do minus 17x and minus 17x. So 3x plus 8 equals 29. Subtract the 8. So 3x equals 21. Divide by 3. X equals 7. And then look back. Okay, this was an hourly rate, so here your x $20 an hour, $17 an hour. So it means it's going to take 7 hours for the two surf shops to come out equal. And then you need to go ahead and figure out what y is going to be. So it doesn't matter, I'm just going to go with the top one. Y equals 20, and then for x I'm going to plug in my 7. So 20 times 7 plus 8 would be 140 plus 8. So y equals $148. So after 7 hours, renting a surfboard would cost $148 regardless of which surf shop I chose. Alright guys, so let's take a glance at your homework. If you want to pause and get your homework paper set up, that's more than okay, but you are doing 2 through 16 evens. There's a few things that I might point out just to kind of get you on the right track. I feel like number 2 is very normal. It should be very, very much like the word problem that I did with you in your notes, so I don't think you really need any pointers or encouragement in that one. Okay, but let's take a look at number 4 and talk about maybe getting that set up correctly. I feel like number 4 is a little bit different from what was in your notes, so we should talk about a couple things on that one. Okay, for this particular problem on number 4, let's take a look. Okay, Helene invested a total of $1,000 in 2 simple interest bank accounts. One account paid 5% annual interest and the other paid 6% annual interest. The total amount of interest she earned after a year was $58. Find the amount invested in each account. So here's why this one's different. Okay, in the problems we did, we would say, oh cool, there's 2 accounts. I need to write one equation for each account. Well, this one's different. They don't want you to write one equation for each account. She invested a total of $1,000 in 2 different accounts. So I want you to think of your 2 different accounts as like she's got account X and she's got account Y. And when they tell you that she invested a total in both, it's kind of like, think of it this way. When you add up what she invested in account X plus account Y, she invested a total of $1,000. So it's different. It's not a slope-intercept form one like number 2 will be. Okay? And then I wanted to talk to you about the interest to make sure we don't do anything crazy with that. When they tell us things like, hey, one account had 5% annual interest and one paid 6% annual interest, I want to remind you that you don't put percentages in your algebra equations ever. When you run across a percent, you write it as a decimal. So 5%, be careful, that's not 0.5, it's 0.05. 6% is 0.06. And guys, they're telling you that she earned a total of $58 in interest. That's from both accounts. So what they're saying is that she earned 0.05, okay, 5% from account X plus 0.06 6% from account Y, and she made a total of $58 in interest. So I felt it fair to help set that one up because that is definitely different than what we did. So I don't want you to get so locked into just because the one we did in the notes was slope-intercept that they'll all be slope-intercept. So you can decide if you guys want to do that one with substitution. You could get one of these letters on top alone pretty easily and do substitution. I think that's fair. I also think since your x's and y's are lined up, if you decide that you want to maybe multiply that top equation by something and try to do elimination, I think that could be a valid option too. Okay, so just kind of be flexible. Use everything we've learned to your advantage to help you out. Okay, and then on number 6, I want you, again, help each other out if you have to. Think about it. It doesn't necessarily have to be slope-intercept form. Okay, think about what you could do as your 2 equations. Like for number 6, I'm not going to write this one out for you. Okay, but the school band sells carnations on Valentine's Day for $2 each. Okay, guys, there you go. Y equals 2x. They sell carnations for $2 each. Okay, it buys the carnations from a florist that charges them 50 cents each, plus a $16 delivery charge. Okay, that can be kind of in slope-intercept form. Think about how you're going to set that up. Okay, but I gave you the first one. Y equals 2x. Done. Second one, okay, is going to be y equals something else x plus a flat fee. Okay, so I think you should be okay with your verbal ones from there. 8 and 10 are your table problems, which I think you guys can do pretty well based on what we talked about. I do want to give you a little warning on table number 10 that throws people sometimes from year to year. Okay, when you look at table number 10, sorry, I'm showing you 9. Okay, on table number 10 right here, I'm struggling. Okay, when you go to do the slope, there's a definite pattern here, but I also want to point out that this is going up by 5s. So you'll do, what's the change in y? Figure it out. Change in x is 5, so do change in y divided by change in x. Be careful with that, okay? And then make sure when you back this up to 0, think about what's going to be that. So be cautious with that. And then here I wanted to look at 12 through 16 just to help you understand that, guys, these, we didn't do ones that were specifically graphs in your notes, but it's pretty much the same rules as from a table. You need to find slope and you need to find y-intercept. Guys, it's slope-intercept form that you're going to write the equations of these lines in. Okay, so if you guys wanted to even set up number 12, you guys could set that up pretty easily here with me. Okay, they're definitely going to be y equals mx plus b because you're doing slope-intercept form for sure. Okay, so look, you can tell right there. Let's do the red line. Okay, let's do the red line first just because. Okay, so it's y equals, or you could say f of t equals, okay? But you need the slope, okay? Guys, that's where you're going to do y2 minus y1. So you're going to do 610 minus 360 over 5 minus 0. So do that over 5 and find the slope, and your y-intercept is 360. So I kind of got you started. Like, I'm not going to find the slope for you. You find it. But you're going to have y equals something x plus 360. Okay? See the blue line? Okay? Find the slope. You're going to do, here's 610 minus 210, so 400. 5 minus 0, 5. Do 400 divided by 5. There's your slope. Plus 210. Okay? So you're going to write the equations. Okay, and then basically once you do that, I mean, they already gave you the answer. The answer is 5, 610. But they ask you, okay, describe the meaning in terms of the models. So they want you to write the system, good, but then tell them what 5, 610 means. So you have to look at these. Time in hours, apples picked. Okay, so you would write a description like this means that there were 610 apples picked after 5 hours. Okay, so that's what they're wanting you to do. They already gave you the answer. You don't need to solve it. They already solved it. But you do need to write the system and explain what the answer means in the context of the problem. So you guys should be all good from that point. 2 through 16 evens. Good luck with writing your systems. Help each other out. Don't get frustrated. We'll go over things tomorrow.